So our learning targets yesterday were about long division, which we just did a warm-up on. There was also a little bit of synthetic division on that warm-up, but I didn't assign practice on synthetic division because we're going to do a whole bunch of it today. Today we're going to learn about what the factor theorem and the remainder theorems actually say. And we're going to talk about predicting. Okay, let me find a pen here. Predicting the remainder by evaluation, and then writing a factored polynomial given the zeros. That's the last part of the lesson. And then find all the factors and write things in factored form is all part of this. All right. So this is factoring a polynomial. It says, how can division be used to factor polynomials? Suppose you are given a polynomial function and you're given one of its linear functions. You can completely factor by dividing and then using that, what we call depressed polynomial at the end, or that quotient, to further factor and find the rest of the zeros. So this one says, use division to write, and we're going to do, well, do you want to do one long division, or do you want to go straight to synthetic? Okay. Why can I use synthetic? That's what my question should be. Yes. This is just an x minus c factor, or linear factor. X plus or minus some number is allowed to do the synthetic. Okay, so this is an x cubed. Mine is a blurry mess, but our coefficients are 1, -5, 2, and 8, and we don't need any placeholders, right? We have a constant, an x to the first, x to the second, x to the third. What goes in the box at the top, though? This is what students mess up. The 0 of +4, right? This has to be the 0 that goes in here. All right, then the rules are, bring down the first one, and then it's multiply, add. So if I bring down the 1, 4 times 1 is 4. I add going down and get -1. 4 times -1 is -4. I add going down and get -2. 4 times -2 is -8. I add going down and get 0. If it said is a factor, your remainder should be 0. Or if the graph shows that there's a 0 at that spot, your remainder should be 0. If it doesn't work out that way, and you can't figure out what you did wrong, even on a test or quiz, bring it up to me and say, I know this should be coming out 0 and it's not. Can you show me where my mistake is? A lot of times it's adding, 1 plus 0 and getting 0 instead of 1 or something silly like that. But once you do it, it's easy to make that mistake. Okay, we're supposed to find the rest of the zeros. What does this mean? What is we had an x minus 4 that is a factor. What are the leftovers right here? Okay, everybody good? This is a constant. This one gets an x, this one gets an x squared. All right, so then they want us to use factoring to finish this problem. We can factor this polynomial with, let's see, a -2 and a +1. Does that work? We'd get an x squared minus 2x plus 1x would give us a -1 in the middle and a -2 at the back. Everybody okay? That was the factor they gave us from the beginning. Yep. So now determine the zeros of this function. What are all of the zeros of this function now that we have it fully factored? 4, 2, and -1. So these are called linear factors because they are all down to just an x, and these are the zeros. So if I were to look at the graph, what can you tell me about this graph? Should have x-intercepts at all these places, right? Okay. And only at those places, since those are all the factors. All right. Consider this polynomial. We're going to divide this by -4, so, or by x plus 4. So we're going to put a -4 here. What goes across the top? Anybody quickly? -4 and 41, right? We don't need any zeros. Okay, can you do that quick? Bring down, multiply, add, multiply, add. Use your calculator if you're not good with signed numbers. Multiply, add. See if you get the same remainder as I did. I probably did something wrong. Somebody else got this? Okay. Anybody having trouble? All right. This is the remainder theorem part of the lesson today. We're going to learn what happens if I put in -4 into this function. So grab your calculator and type -4 to the third plus -4 squared minus 4 times -4 plus 41. I'm going to do it without a calculator and get the wrong answer. No, I'm not. Okay. Did somebody get a 9? Is anybody not getting a 9? I would type it just like this with all the parentheses and everything. But so what we found is the remainder. Why would this be helpful? Well, if we wanted to know if there's a 0 at -4, we could plug it in and see if it comes out as 0 or not. Or we could do synthetic division and see if the remainder is 0, right? Whatever seems to take less time for you. Those are always going to be equivalent, okay? Let's see, I think the next slide has us write some notes about that. It says if a polynomial is divided by x minus c, the remainder is the same as putting c into the function, okay? This process is called synthetic substitution. It allows you to do synthetic division instead of plugging it in, or the other way around. If you use the remainder theorem to evaluate a function at c and the result is 0, that means there's no remainder. It means x minus c is a factor meaning it goes in evenly. Polynomial f of x has a factor x minus c if and only if when you put in the c you get out a 0. All right, that is the factor theorem. States that x minus c is a factor if and only if f of c is 0. All right, that's what that looked like on your paper. So we are going to do f of 2 for this function real quick. 2 times 2 to the third plus 5 times 2 squared minus 14 times 2 minus 8. You'll be faster on your calculator, but I got 0. Did anybody else get 0? So what does that mean? Is x minus 2 a factor? We put in a 2 and got out a 0. This predicts the remainder, okay? This means the remainder will be 0. So would x minus 2 go in evenly? Yes, if we did a 2, and you don't have to do this, but I'm just reminding you what this is saying. You would bring down the 2, multiply, add. The remainder would be 0. So putting a 2 in predicted the remainder. We could have actually done it and found the remainder. But is x minus 2 a factor means did it go in evenly? So as long as the remainder is 0, yes, it is a factor. Yes? Can I see what you typed in real quick?
On the last one, I said I got 233.
Oh. Yeah. Minus 8. Should be minus 28. 5 times 2 squared. On this one, the first one here should be a 3. It's a 2x cubed, and you have a 2 up there. Okay, yeah, so I think it's just typing error, but I can look at the other one with you in a minute if you want me to. We can go back and look. All right. So if we want to know what this is when it's divided by this, okay? I want us to actually divide because this one is going to need some placeholders, I think, right? So we're going to do what in the little box? Do you have this problem somewhere? Yes? Okay. Gonna. Oh, is this a problem we just did? Okay, hang on. Where are we at? Oh, is this? Oh, we did it. It's number 5 at the top. Okay. All right. See the top of the page was, we did this problem yesterday. 1, negative 3. No. 0, negative 3, 0, 12. Is that what we did yesterday? We brought it down, multiplied, added. Multiplied, added. Did we get 10 yesterday when we did it? Phew, okay. So how could we have checked our answer is their question. We were doing x minus 1. You could check your answer by finding f of 1. That would be pretty darn easy to do, right? A 1 to the 4th minus 3 times 1 squared plus 12. I don't even think we need a calculator. This would be 1 minus 3 plus 12, which would be negative 2 plus 12 is 10. So they're just showing that that is a way to check. Does the remainder equal what you get when you put the value in the function? We'll put the 0 in. All right, that's what the remainder theorem is all about. All right. Moving on. So it says if f of x equals this, find each f of c. We can either do direct substitution or synthetic substitution. Direct substitution, if somebody wants to do that, would be this guy. But if you don't like that, you don't want to grab your calculator, you could also do the division. Yikes, I'm definitely not getting 0, but maybe I did something wrong. 56. I got 58. Did anybody do it this way and get 58? $58 both ways? So, is x minus 4 a factor? No. You could say either f of 4 does not equal 0 or there's a remainder. And I ran out of room. All right, so we are going to practice this. And some of them we're going to need our calculator for. But the first one, it says use the factor theorem to determine if the binomial given is a factor, and then use the binomials to write it in factored form. So this is what we did at the beginning of the lesson. They give us one of them. So what are we going to put in first? We're going to do synthetic division. In the little box is going to go -5. We have to do the division. We can't just substitute it in because we're going to need that depressed polynomial at the end to continue factoring. So across the top is a 1x cubed, a -2x squared, a -29x, and a 30 is a constant. So we should be okay without any placeholders, right? Bring down, multiply. Somebody tell me what to write here. -5, add and I get, multiply and I get, add and I get 6, multiply. Okay, they told us it was a factor at the beginning in the direction, so it better be 0 or we did something wrong. Okay, this is again called the depressed polynomial. And as long as the depressed polynomial is down to a quadratic, we're pretty good at factoring them. This is a 6, a -7x, and an x squared. So we have an x squared -7x and a +6. X -6 and x -1 would give us a -6x and a -1x out here, which would give us a -7 in the middle. So what am I going to write for completely factored form for the original polynomial? I can write x -6 and x -1, but what else do I need? Yes, the x + 5 that they gave us. Because an x and an x and an x would be the x cubed here. We got to make sure we get back to that original leading term. All right, then they get a little more complicated. You have to actually graph it on your calculator and use what's called successive division, and this is important for the quiz. Successive division means one right after the other, okay? Your courses over the course of the day, your periods go successively, period 1, period 2, period 3, period 4, okay? It just means one right after the other. So we have to divide these in without going back and starting over so that we get down to something we can use. So I typed the first one in. Everybody should do this. 3x to the 4th plus 8x cubed minus 15x squared minus 32x plus 12. Because if it's not working on the calculator, we need to know it. You can try a standard window. It's not looking too good. Do you want to take time to adjust the window? We really only care about the x-intercepts, so if you don't want to adjust the window, it's okay with me. I think it's the y values we'd want to adjust to, like, I don't know what. I'm just going to go to like -50 and 50, except I did those wrong. That might be a really crummy window. I have no idea. All right. The bottom line is you care about the zeros. And some of them aren't nice. Can anybody tell where there's a nice one? Where it looks like there is a nice one. Give me something to test. You're going to go trace. And what do you think? -2? Okay, -2 comes out a nice one. We might want one more nice one. -3. Looks like it comes out nice, okay? If we picked positive 2, comes out 0. If it doesn't come out 0, then there's a problem, and we can't use that. It's not a nice one. We're going to have to divide at the end. All right. I got all this stuff in the way now. I don't know if I changed the window or what I did. All right, let's go back up here. Okay, so the original polynomial was a 3x to the 4th, an 8x cubed, a negative 15x squared, a negative 32x, and a positive 12. Lovely. Didn't need any placeholders, but it had a lot of places. Okay, pick one that we did on the calculator. Which one did you like? Doesn't matter which one we do first. You want to do negative 2? Was there a positive 2 that worked too? Okay, doesn't matter. We can do positive 2 in a minute, or we can do negative 3 in a minute. Okay, if it worked on the calculator as a 0, what should my remainder be? 0. Okay, bring this down, multiply, add, multiply, add. Ooh, negative 19, that's a nice number. 38, add is 6, negative 12, ooh, came out 0. Right, this is where you don't go back and start over. You keep dividing. Successive division means you do one after the other. So this is our new polynomial, minus the remainder. This is our new polynomial we're going to divide into. What was another one that worked? Doesn't matter any order we could do these in. Positive 2, okay? Bring this down, multiply, add, multiply, add. Now, we could stop and factor right now in this would factor, or do you want, since you found one more, do you want to do one more division? It doesn't matter. I can show you that it doesn't matter, but we had one at negative 3, didn't we? So if we brought this down, we'd have 3, negative 9, add is negative 1, multiply is 3, add is 0. Okay. So the completely factored form, what were the factors we found, guys? Negative 2 means I write x plus 2, and I can list negative 2 down here. Then we did 2, and again, these can be found in any order. So we had a positive 2, and then we had a negative 3 as a 0, and the factor was x plus 3. But that's not a degree 4. What was the leftover polynomial we had? 3x minus 1. Okay, that was this guy at the end. And if we set 3x minus 1 equal to 0, we get 1/3. So we found one that wasn't quite so nice at the end. If we still had it pulled up, we could type trace 1 divided by 3 as a fraction, and it should come out exactly 0, or some silly approximation from calculator error. Okay, how we doing? I did want to show you real quick that right here, I could have stopped because I was down to a quadratic, 3x squared plus 8x minus 3. If you're a good factorer, this would be a plus 9x minus 1. Do you see that would have taken care of those last two terms without doing one more division? Okay. All right, we got one more to do. Can you type this bad boy in and tell me what are some zeros that come out nice? It's 4x to the 5th minus 12x to the 4th minus 13x to the 3rd plus 39x squared plus 9x minus 27. And the reason we're not just finding all the zeros is because some of them aren't rational or nice, and we can't write down decimals. We have to have nice factors. Anybody get some or not? 3. Yep, and you want to test them, don't just assume. 3 is one. Anybody else think they? -1 works. It comes up as 0. It's got to come up exactly 0 down here. +1 or not? Okay. All right. Anybody having trouble because they didn't get it graph right? So what did we come up with? No. -1, +1, and +3? Okay. That should be enough because that would leave us 2 more to find because it's a degree 5. And those might not be nice ones. All right, what do you want to start with for the divisions? Do any one first. 3? All right, let's do a 3 with a 4, -12. Do we need any placeholders? I don't think so. There's enough ugly numbers without any, right? All right, I'm hoping for some zeros. I bring down the 4. 3 times 4 is 12. That one does give me a 0. Then 3 times 0 is 0. Bring down -13, add and get -13. Multiply and get -39. Add in that one 0. 3 times 0 is 0. Bring down the 9. 3 times 9 is 27. Remainder 0. So we didn't mess up yet anyway. Do we go back to the original? No, we keep going. Anybody lost or didn't get that? You okay? All right, do you want to do -1 or 1 next? Order doesn't matter. +1, okay. Bring down the 4. 4 times 1 is 4. 1 times 4 is 4 again. -9. 1 times -9 is -9. Add is still -9. 1 times -9 is still -9. 0. Anybody else have 4, 4, -9, -9? Sounds like we could factor by grouping if we were. Anyway, we have one more we know for sure was a -1. And again, you could have done these in any order. You would have got the same thing at the end. Bring down the 4. That'll be -4. Add is 0. Multiply is 0. Add is -9. Multiply, get +9. We got 0. Okay. So I have zeros at -1, 1, and 3, but it's a degree 5, so unless we have a multiplicity, we have a couple more zeros to find. What factors do I have so far? A -1 means there's an x plus 1. A plain old 1 means there's an x minus 1. A 3 means there's an x minus 3. And what does this leftover business over here mean? 4, yeah, this was a constant, this is an x, and this is an x squared. So I have 4x squared minus 9. Can that factor? Because it's not a linear factor yet. It factors how? 2x minus 3 and 2x plus 3, because those are perfect squares. All right, I don't have room. I got to squeeze in there 2x minus 3 times a 2x plus 3. Okay, that should all be in one big long row. And where are the zeros for those? 2x equals 3 would be 3 halves. And -3 halves, does that seem right? 2x equals -3, x equals -3 divided by 2. You don't need to show all that work if you don't need to, but is everybody good how we found all 5 of the zeros? Now, it is possible at the end that they will be irrational. For example, at the end of that question, if I had gotten x squared minus 7, I would have had x squared equals 7, x equals plus or minus the square root of 7 is my last two crazy factors, okay? So this is a summary of everything we talked about today. So I'm not going to go back over that. That was an extra example. Maybe we could start with tomorrow. 8B and 9A, you have to do the circled problems. Can somebody check? Is it just like 3 questions? 4? Okay. 4 questions. Just the 4 circled problems. Where do you start these? Because you're going to get confused when you go home tonight. You start by graphing it on the calculator, okay? Graphing it on the calculator. So when you look at it and you go, I don't have any clue. Well, start by graphing it on the calculator to find some. Everybody good?